So my name is John Morton. I'm a professor of nanoelectronics at the London Centre for Nanotechnology, which is where I'm standing now, and also at the Department of Electronic and Electrical Engineering, where I do my teaching. I'm also director of UCLQ, which is the UCL Quantum Science and Technology Institute, which covers all the research around UCL looking at quantum science and technology. So quantum physics is a very old theory that was developed at the beginning of the last century, and really the ideas that quantum physics gave us allowed us to develop the semiconductors and the transistor and the laser, two inventions which really shaped the last century. But it also produced some really strange and wacky ideas like superposition, the idea that something could exist in two different places or two different states at the same time, and other ideas like entanglement. And these concepts haven't really been harnessed in any technology that we use today. And so what quantum technologies are about are using some of these ideas to make new kinds of computers, new kinds of sensors, new types of secure communications channel, which fundamentally outperform any technology that we have today. At UCL, we have different programs at a range of different levels covering quantum technology and quantum science. So we have a PhD program, which is a 4-year integrated MRes and PhD, which gives people a foundation in quantum technologies over the course of a year through lectures, labs, hands-on experiments, visits to different companies developing quantum technologies, and really provide students with enough knowledge to then make choices about which projects they want to focus 3 years of their life on for a PhD project. Before that, at an earlier stage, we have a master's, an MSc in quantum technology, which is a 1-year program. And there's even opportunities at an undergraduate level in courses like physics, electrical engineering, computer science, for students, especially towards their 3rd and 4th year, to interact more closely with researchers at the forefront of quantum technologies, perhaps perform some of their research projects with those groups. One of the strengths of UCL's Quantum Science and Technology Institute is that it doesn't just focus around one particular quantum technology. It covers the full breadth, from quantum computing to quantum sensors, quantum communications channels, and lots of different platforms as well. And then more fundamental ideas like, are there quantum effects in biology that nature uses? What does thermodynamics mean at the level of quantum physics? So there's a very broad range of topics that people are working on within UCLQ, which students can get involved in. Traditionally, because this area grew up around very fundamental theoretical ideas in physics, traditionally the standard student has come from that kind of physics background. But we've really seen that transform over the past few years, and we're seeing many more students coming from electrical engineering backgrounds, computer science backgrounds, and other backgrounds that are more technology focused. And this is going to be really important for helping the field move from fundamental science through to practical technologies that will ultimately impact society. So we're strongly encouraging applicants to our programs from those kinds of engineering and computer science backgrounds, as well as from physics. The opportunities to students after taking one of our quantum technologies degrees have been growing rapidly over the past few years. Traditionally, there's been the option to move into further research within universities, but because of this very vibrant commercial and industrial activity that we're seeing in quantum technologies, there's now a very wide range of different options for students, either going into big companies like Google, Microsoft, but also from startups we're seeing both in the UK, in the US, and around the world that are all trying to recruit. So it's really an area where I'd say there's a skills shortage. And so if you're graduating from one of these programs, you have a lot of choice about which direction you want to go in.